you all for joining us for Tech Tuesdays with ATIMS and Friends. And today we'll be going over 3D design with Tinkercad. Sessions that we have remaining includes March 12th, April 9th, and May 14th. I'll put that information in the chat for you. These are some of the past sessions. And if you haven't had an opportunity to check out Tim Talks, please do so at your earliest convenience. Tim Talks is an episode hosted by Angela Clark and myself, who happens to be our presenter for today. And today, the latest episode that we have is ready for more in 2024. If you get an opportunity, please check that out. We try to make you aware of different initiatives across the state, as well as how we can provide service to your district, your school, or your classroom. Please reach out to us and also take a listen to Tim Talks. You can listen to us on Spotify, Amazon Podcasts, Apple, as well as Google. So we're easy to find. And also, this year, Alabama Educational Technology Conference theme is Game On, leveling up with educational technology, which will be hosted in Mobile, Alabama, June 19th through the 21st. So please take an opportunity to register for that. And I think there's 4 free available registrations for at least 4 members in each LEA. So I don't know exactly how that works, but that information will be placed in the chat as well. Also, during that week, you have assistive technology free conference as well as STEM in the gym. So it's a little something for everyone. No one is excluded. And then, of course, we have our mega conference, which is in July 8th through the 12th, 2024, also in Mobile, Alabama. Our meeting norms for today. We're all learners. While we may have a different level of understanding of the topics, we're all able to learn from one another. We want you to be fully present. Our schedules are always busy, but it's important to take the time to participate in professional learning. So I do want to say thank you once again for being with us today. We all work together. We collaborate to maximize our impact on student achievement and success. Every child, every chance, every day is a non-negotiable. My name is Pernell Allen. I'm the Alabama Technology and Motion Specialist located at the University of Alabama at Birmingham, UAB. Go Blazers. That's my contact information right there. To the left are the other universities where regional in-service centers and ATIMs are located across the state. Region 5 serves the following LEAs, which includes Bessemer, Birmingham, Empower Community, Fairfield, I-3 Academy, Jefferson County, Legacy Prep, Leeds, Magic City Acceptance Academy, Midfield, Tarrant, and Trustfield City Schools. However, our guest speaker today, is my friend, colleague, Angela Clark, who is out of the University of Montevallo, which is Region 7, serves the following LEAs, which is the Alabama School of Deaf and Blind, Alabaster, Bibbs, Chilton, Coosa, Homewood, Hoover, Mountain Brook, Pelham, Shelby County, Sylacauga, Talladega City and County, and Vestavia Hill City Schools. But at this time, I will stop sharing and turn it over to Angela Clark.
All right. Thank you, Pernell. Good afternoon,
You're welcome.
I hope you all have had a wonderful day of school. Happens to be Mardi Gras. I grew up on the Mississippi Gulf Coast, so that Tuesday, oftentimes we were not in school, but I know it's not that way up here. Anyway, this is probably one of the funnest things that I get to do as a technology and motion specialist. And Pernell's right. We partner up. We've gotten to be great friends through our adventures and many failures with 3D printing and designing. But we have learned a lot in our journey to become, I'm not a perfectionist at 3D printing, but we definitely seek it. And we are always trying to become more precise, better designers, and just see how we can push the limits. And we do all this not just for ourselves, but also so we can best inform you, our learners. As we get started, I will share my screen and I have some resources to share with you. A couple of those I will share in the chat, just so you have quick and easy access. And I'm working off my laptop, so one screen as opposed to many that I'm used to. let's see. Pull up the chat first of all. Oh, great. We've got some resources in there. I will share my screen with you all. And I do have a video clip, so I will go ahead and click that button. All right, so you should be seeing my screen. I'll share it nice and big for just a second. Oops. Clicked the wrong thing. There we go. Because there is a QR code there. If you would like, there are some links throughout the presentation. These are really just slides that are for resources. So this isn't actually my presentation because you're going to get to take a peek at Tinkercad today. But that QR code you can scan and it will give you these slides. There are quite a few things linked, and there are even some ideas for introducing 3D design and 3D thinking to students already in this slide deck. So I wanted you to make sure you had access to that. And then there is a handout that is linked at the bottom of that first slide. And it looks like this. I'm just going to pull it up real quick. And I'll refer back to that a couple of times. When we do our in-person trainings, oftentimes I don't do a paper handout anymore. But for this one, I always do because I think that having a look at the process is very helpful. Move my Zoom bar real quick. Go speed it up. I'm going to copy this one. Let me pop that in the chat for you all. So if you have been introduced maybe lightly to 3D printing, or you're just looking for more resources, or maybe you just need some practical applications, that handout has all kind of hyperlinks all throughout. And everything is labeled. Some of the links are more for students, some are more for teachers who are just learning. Others are related to like how 3D printing is used in industry. So I'll touch on a lot of that, but in an hour, we're probably going to cram 6 hours worth of learning in. So I won't be able to go too deep into any one thing, but I wanted you to have those resources out as we get started. So that's your parting gifts for the presentation. Okay. So 3D printing. What is it? What is it about? You can probably guess that it means three-dimensional, right? We call it a design experience because when you want to 3D print, you really do first need to design. And in order to design, what we like to say is put on your design hat, but you also have to learn to think in 3D. Okay. So when we draw on paper, we know that's two-dimensional. Okay. When we design in 3D, we have to add a dimension. And that is what we refer to as our z-axis. So if I have an object that is not flat, but it has that third dimension, the z-axis built, then I have to envision that printed in 3D when I'm designing. So that takes some getting used to because we're not really accustomed to being able to print in 3 dimensions using one layer at a time that stacks up on top of each other. But there are so many things that you can print, and actually have something hot off the press that I just went down and pulled off my printer. And it's just a little luggage tag or maybe a background of a luggage tag. And this is the base plate that came out of my printer. It just slides out. And then you probably hear it crack. Here, let me hold it up close so you can hear it. It's going to peel off. It's a flexible plate. This one is. You have to work it a little bit so that when you don't want to break your plate, and you don't want to break your plastic filament build that you just built. Let's see if we can get it off. I'm taking a risk doing this live. There we go. All right. And it came off nice and cleanly. Now my plate's ready to put back into the printer. Now, this didn't take much to design, but I could have customized it, adding letters and layering more on top of it. This one happens to be in a transparent filament. Yes, there's a whole nother set of vocabulary that goes along with it. And it's printed on a raft. So it's going to take a little bit of time and some tools to get that raft off. But I can actually paint or Sharpie this. So you can color filament. And when you use transparent filament or clear filament, that can be super fun. So you let your imagination run wild. You'll learn to think in 3D, which means designing. There's some math. I already mentioned X, Y, and Z axis. There's also some measurement that's involved. And then this is really exciting because for you and for your students, you get to think innovatively. Like, what are the possibilities? They're endless. They're truly endless. You can think entrepreneurially. What can we maybe make to sell? What's a design that has a flaw that we can make an improvement to? What's something we need to print so that we can fix something we already have? Thought processes tend to change and go super high level when you're thinking of in 3D. All right. And around this particular slide, some pictures of work with students, work with teachers, the excitement on faces. Pernell, you got to pop in real quick. Like, teachers get so excited at their first build, don't they?
Exactly, they really do. It's an experience. We even have, like you said, it's another set of vocabulary. So I do see the people holding in the first, second, and third place 3D printed
Mhm.
trophies right there. Just
Yep.
understanding the vocabulary with the blue game included. So we try to incorporate multiple tools whenever we do these presentations. Yes.
Awesome. Yes, the excitement for teachers when they have that first successful print, because you have to get ready to fail. If you're going to delve into the world of 3D design and print, actually print, you have to know that there will be failures. Not everything comes out perfectly. And I'll show you some of my failed print here in just a minute. Sometimes things just tip over. Sometimes your printer wasn't quite oriented. And folks, sometimes the failure is in the design itself. So that's why getting a really solid foundation built in what you know and can do in Tinkercad is important, because that'll at least eliminate or hopefully eliminate that your design was the problem. A lot of things can go wrong when you actually go to print. And of course, that requires more of an in person experience. I can't really teach all of that today. But I've got some prints where I can show you some different things that happened and maybe how I would have prevented that. But first, as we get started, so I mentioned a couple of things that 3D printing touches on. And I wanted to mention that there's really no content area that we teach that's untouched potentially by 3D printing. And more industries across the board, there's some connection, some way that industry is impacted or will be by our ability now to 3D print. In a lot of cases, the one thing holding us back is we just haven't experimented or perfected the material that we need. So they're printing orthotics and prosthetic limbs for not only humans, but ducks. There's a video. I've got this in the slides so you can watch. I'm going to show you right now how they 3D print houses. We'll watch a quick clip because this is really amazing. And then you'll even see that they can 3D print sporting equipment, satellite replacement parts, and food. Completely fascinating, right? All right, here we go. Let's hope if the video sound doesn't play through, y'all let me know.
Here on this site, we're building the first 3D concrete printed home in the state of Virginia. We were lucky enough to receive a grant from Virginia Housing that would allow us to demonstrate an innovation in practice in the field. And so we partnered with a group out of Iowa called Alquist 3D and the local general contractor named RMT Construction. And together we're commercializing a new innovative process into the market, and that's 3D printing. If you look at the rest of the world, many build with masonry, in fact, a majority of it. And this is going to be a lot like what you would have with a masonry home or a brick home in terms of its durability, its quality. This is something that's highly customizable. It has the ability to have any kind of finish you want. If you don't like concrete on the inside, you can do many other types of finishes, but it's very durable on the outside as well. I would really compare it to if you had a brick home, except this time it's going to be concrete. Some people might like the pattern that you have from printing. Some people might not, so we would actually cover that pattern up with some kind of a coating, a skim coating. Graduate students are helping us with measuring the house in terms of its performance after it's built. They've been helping us from the beginning with planning how the house would be designed and how it would be highly efficient in terms of energy. They're helping us with understanding the costs and the process and the schedule, all of that. So we've been working with graduate students from the beginning to help plan this house and make it happen. In the United States, we've always had a lot of access to wood, less so now, and certainly less so in the West. You have areas of the country where a concrete house makes a lot of sense, like Northern California or parts of California where you have fires. I think you're going to see more and more, especially from the code side of things, that is great for building in dense populations where you have people right up against each other and you want to protect for fire and sound and you want to have high durability. We're going to see more and more of this kind of construction.
This is a cluster full of high-value customers with untapped buying potential. MailChimp uses real-time behavior data to personalize.
All right, my computer's a little slow to respond, but how about that? All right, I cannot see anyone, so hang on. Let me come back over here. Thoughts? Anyone want to share a thought in the chat about that, what you just saw? What are the implications for being able to create and build homes that maybe can withstand, natural disasters, like he was saying, fires? Think about the number of people it takes to build a home. The machine, that extruder, that giant extruder is part of the 3D printer that they're using, and they figured out how to pipe in all that concrete. But you could really see one layer at a time going down, couldn't you? Like, that's just so cool. Guess what? It's the same process that I'm doing in my living room downstairs to 3D print something that looks like this. It's one layer at a time. Now, this is minuscule, but bitty. And it's, of course, laying down on a base plate, and it's plastic filament. We call it PLA filament. But it's the same process. Amazing. Here's a little piece of history for you. Can't have the class go by without mentioning that in 1986, a man named Mark Hull had his process. His process was stereolithography printing, which is similar but not exact to the FDM or fused deposition modeling that we often see in 3D printers for schools. But his is a fancier type, but he patented the process. So talking about just intellectual property and entrepreneurial ideas, that was in 1986. Look at where we have come now. So I just want to pose the question, like, where do we have left to go? Oh my goodness, the possibilities are endless. Purnell and I remember when we saw that video of the way they actually are putting 3D printers onto non-working satellites to try to repair them and repurpose them. We saw this video and we both looked at each other in awe. We were like, what? They can't send people up there as easily as they can a 3D printer. And through robotic work, they program it to print while it's out in space. That video is fabulous. So a quick little collection of videos I gave you, and just in case you are wanting to show some of those to your students. But I'm telling you, if that doesn't create curiosity, I don't know what will. All right, let me share my screen back again. I had to pause for that little tidbit. I'm like, there's no way to really show you on the 3D printer without some video content. All right, so what you'll see on the handout is that process that I just mentioned that was patented. And so I'm going to scroll up a little bit. That information should be on here. There it is. It's on page 3. So you can see here that Mark Hull's process was a little bit different than the process to 3D print now, but that patent and the work that was done after it has been critical in where we are now. They are even experimenting with, or there's being research being done on materials that would allow us to print human tissues, organs. And when you think about just improving quality of life and saving lives, the implication that has for the medical industry is, now there are some ethic involved in some things that you could 3D print, but it's just really impressive because it is actually going to be possible. All right, so let's talk a little bit about Tinkercad. First thing I want to mention is there are some terminologies that you're going to want to get used to. A couple of those I'll mention throughout the little tutorial that I'm going to do, but knowing that this list of resources is here, I hope will just help you remember, like, I can always go in and just explore some projects or get an idea of what lesson plans I would use. Like, how would I use this in my classroom? I teach math. You can look up some ideas for that right here in Tinkercad. And then I'll show you another place to go just to get inspiration for designs. There is also a tutorial that I linked, because if you haven't ever used a CAD program, which is just an acronym for computer aided design, which is what we use when we're trying to design for 3D printing, you can do a whole lot more with your designs than just print them. Like, you can create animations. It is considered actually artwork or original designs. So if you're wanting your students to do this and you don't have a 3D printer yet, hey, anybody can design. And Tinkercad is the most trustworthy program. And Pernell, if you have anything to add on that, I don't know that I've run across anybody that's had it blocked. However, we never know how districts decide whether to allow a program or not, but it's the most student-friendly product out there that is free. And what I really like about it, and I'll do a quick tutorial on setting up a classroom, not the Google Classroom type, but a Tinkercad classroom, is your students are safe in there to design, and the designs are all auto-shared with you. So that's why I like to promote Tinkercad. For now.
Oh, yes, just I was gonna add, you covered it right there, just saying creating that class, being able to leave notes on the students' designs or what have you. So that I think that's awesome. No, I have not heard of any schools having it blocked. It varies from district to district, so I don't know. But just the schools we've dealt with so far has not said anything about it being blocked. So that's a great thing.
Good. I
And you
agree.
mentioned something. You also mentioned something about once you design it, they do have sim labs. So that may be something for a different topic for a different time, but you can explore that. So you can look into that and do the sim labs to see how it would actually function in the real world. So that's just another idea to throw out there about Tinkercad.
Exciting. Like, you can totally prototype in your living room or at school. I went to school a long time ago. Back in the 80s, there was nothing like that around. We didn't even have a clue that would be a possibility one day. So I just think it's really exciting what the potential is for learning how to design in 3D. And like I said, you do want to teach your students how to think in 3D, how to picture. A lot of students, if they're, fourth grade and up, they've had some experience with the X and Y axis, right? Graphing. So to add that dimension just means, okay, instead of across and front to back, we're adding up. From the base plate up is our Z. And so if they can just think in that third dimension, that will at least give them a good starting point. And then key to your success and student success with learning about 3D design is some common vocabulary. Some terms that, sure, they mean one thing in the normal world, but when it comes to 3D design, it probably means something else. Okay. So when you think about a raft, like most people would think, oh, something you blow up and use in the swimming pools. But in 3D printing, that is on your design or laid down first on the base plate so that your object or your design has stability. And this is taken off of the design after it's printed. So the raft is this little piece here. And Purnell has helped me build my confidence in learning how to print without a raft. So you can print without one. But at first, it just comforted me to know that my raft was going down first and my build wasn't going to go sliding around on my base. So some people use glue, use a little glue stick to help it stick. But on this kind of plate that has this texture, you don't have to use the glue. But sometimes the designs come out a whole lot cleaner if you don't. So that's an area to experiment in once you've gotten good at it. You can think about the end product, if you're going to actually print it, as you're designing. And there is a lot of, I guess we'll say, geometry, arcs, and angles involved in figuring out if your design needs supports. But there are different types of supports that you can put underneath anything that needs it. So there's some kind of guidelines or rules related to that. But the rest of these, I'll probably mention some of them as we go along. I talked about PLA. That's just the type of filament. It's like a plastic biodegradable filament that we often use. And let me grab this one. When it's packaging, it's best to leave it in because you don't want your filament to go bad or get crispy and breakable. You want it to be real pliable when you put it through the printer. But there's all different colors now. There's sparklies, there's shimmery and shiny ones. There's, like I said, the transparent. Is what the MakerBot filament that I often use looks like. It's on one of these big spools, and it's just this plastic. So you can do a little quick test by breaking off a piece to make sure it's not gotten too dry. But in general, it's best to keep it in the vacuum sealed packaging. I just wanted to mention that because that is sometimes a fun thing to find in a closet. And you're like, should I put that in my printer or should I not? And so if you're not sure, do the pliability test where you break a piece off and see if it's bendable. And if it snaps and snaps, probably best to throw it away because your filament is what's going to give you the successful build. And if you've ever dug filament out of the nozzle of your printer, you know how not fun that is. It's actually challenging to work bad filament out of your nozzle. And sometimes you have to replace it altogether, which can be expensive. There's a Quizlet study set if you're interested. I just did a snapshot of some of the terms. And if we have time, we can maybe play a quick Quizlet and see what we remember. And then I'll just mention that I've got a graphic, I think whatever kind of printer, or you can go with a generic one you have. It really does help to understand the parts of the printer. And they really are fascinating. And the prices are coming way down. Who has one? Who has a 3D printer? Lots of folks. Some of you guys do. Who's thinking about getting a printer, maybe? Anybody? Yeah. Let's see if
I see some hands being raised in the chat, and some people saying they have 3 Dremels. Yes, they'll mention it.
Dremels like
So
the Cadillac of 3D printers. I don't have one of those yet. I have one I'm borrowing. Yeah, you can do some fancy stuff on a Dremel. The Dremel that I have downstairs printed this. It's a little froggy. And he's something. He's like in a clear plastic filament. But it can print really, and it's so smooth. Like it just comes out. All right. And there's some origamis that I pulled just because that teaches algorithmic thinking, computational as well as design, and just how to envision your build in 3D. So I really like an origami or even like Play-Doh or Legos for teaching about design. Okay, so let's go investigate some Tinkercad. Are y'all ready? All right. In simplest terms, I will say that we can call our process design, slice, print, and repeat. There's actually some cool, cute t-shirt designs that I found. I'm like, I need that on a t-shirt. But when you slice, you just basically get your design ready for the printer. And then, of course, printing has its own little set of potential failures that you can run into. And then repeating the process. We want iterations. It's not the end of the world if you have to restart your printer 5-10 times. Who's had that happen before? Same design, multiple restart. Woo! That will work your patience. Y'all, it happens to everybody. So I can't tell you how many times I've started a print and I'm like, I saw it not stick to the base plate. I didn't have my calibration done properly, and I had to start over and start over. It happens. Sometimes your build gets almost to the end and it tips over and you end up with having to pull it off and it's not finished yet. But I keep this one because it's neat. You can see the inside. You can see the little infill going on in there. So there's any number of things that can happen, but this is a lesson in patience and endurance. And I think it's a good lesson in learning how to fail and how to persevere through. And if you have done this with students, bless you, that is probably something that you maybe didn't even expect would happen. But to work through those issues and do as many redesigns or iterations as needed really teaches healthy lessons and how to persevere through. Because when you're designing for, say, the space station, or maybe even a competition, or in the medical field, you want precision, you want accuracy, and you want to be able to work through any design flaws. So that's just part of the process. All right. So we're looking at Tinkercad right now, and I do have some classrooms set up, but I'm going to wait and show you that later. If you want to join, it's just tinkercad.com, and you are welcome to pop open a new tab and type in tinkercad.com. If you already have an account, it'll probably still have you click on educator. And then I just sign in with Google, but that is up to you. It's your preference. Because as I talk through this, you very well might want to do it with me. I know it's hard to do a virtual session that way, but I will try to specify my actions so that you can follow along. And this is the best way to learn, with somebody kind of guiding you, or just follow the tutorials that are built into Tinkercad, because they're really good. And they have little explanations throughout that tell you additional information. Right. So when we click on designs, if you've done designs before, if you have any, they'll be listed here. I have a little library going of my designs. And then you'll also see a create button. So when we click on create, you'll notice that there are 3 options. Now, because of the nature of this lesson or this class, we're going to stick with 3D design. But you can go and explore circuits, which I know are often content for 4th grade, can also be anywhere you teach electricity. And then code blocks, if you're wanting to look at more of the code or computer science piece of 3D design. So we want to create a new 3D design, and I'll give a quick overview of the navigation here. I'm going to shrink my menu down so I can see everything. Try not to that get in the way. Okay, there we go. Pop down to the bottom. All right, so this is what your screen is going to look like when you go into 3D design. Now, I'm going to do just a basic overview here and guide you through how to move objects over onto our work plane, and then how to manipulate them a little bit, because that's the foundation that you want to have. You want to be really comfortable with that process. Your title, there's always a default title that some of them are funny or they don't make any sense. You can always change that. Just click on it and change it like you would in Google. But this is the name of our file. And once we're finished, we will either want to export it or download it. And I'll make sure I go over how to do that. You'll also notice right underneath a couple of buttons here at the top that there's a cube. It's helpful to know, and it's not so easy to do this with just the laptop pad or the Chromebook pad, but you have an actual mouse, it's a little easier to do. But if you click on that cube and shift it around, you'll notice that the work plane is moving as I angle this, okay? So this cube has the front, back, top, bottom, left, and right, and we can view our design from any of those angles. And then if we get really lost or upside down or any number of things happen, just click on home right over here. easily take you back to this exact spot here. And then you can zoom in and zoom out. And you can go to flat view if you want to just make sure your design is attached to the base plate or sitting on the base plate. And then across the top, you'll have a bunch of different options that are disabled right now. But once we bring a design over or an object over, those will come to life. And then here are your options for sending. You can co-design with somebody, which that might be fun to collaborate on a design. You can export your file, and you can import other files, which we'll do that last. I'll share a place that you can go and get inspired with ideas, and you can borrow them and bring them in and tinker with them yourself. And then notice below that there is this little library, and you have to click on the drop downs. Let me do that again. It says basic shapes in the drop down menu. Clicking on these two little arrows, though, will show you there are much more, many options to pick from in the library or in the menu. So you can go in and check out all the things that are there. When I'm doing a first lesson, I usually start either here with design starters, or we just say basic shapes. You can grab any shape, and if you click on it and drag it over, drop it onto your base plate, click on or press the D on your keyboard if you just want to make 100% sure that it's set down onto the base plate, because not all of them do that. Some of them end up in the air and you don't know it until later. If you scroll up, you will eventually get to a place where it stops, and something's keeping me from seeing more. Okay, you can click on where it says more at the bottom, but I am not able to see mine. So let me go over here to design starters. There we go, more shapes. And if you scroll up, you'll keep seeing more shapes. So you just, if you don't see something you like, just keep clicking that until something loads up that you're like, oh, I think I'll pull that over. So maybe I've got a little sphere, maybe I want a cube. Is anyone thinking, ooh, awesome for geometry? Our kiddos need to learn their geometry, right? Bring it to life a little bit. Again, you can do this even without a printer. That's fun. Super easy. I'm just bringing a couple of items over to my base plate, and I like to be 100% sure they land on the base plate. So I just tap the D key. That makes it go in place. And then let's just get curious and explore. What else have we got in here? Let's see. Ooh, there's some hardware. Ooh, a spinning wheel. That looks fascinating. All right, so I'm just placing a few different items on my work plane. One, for the practice. I would like to get a car wash.
It's outside or outside and
Inside.
You muted yourself too, Angie.
Thank you. And from here, you can experiment. What I will tell you is this will save some frustration. If you click on the wrong thing or manipulate it in some way and you didn't mean to, just like any other place you are where you want to undo, Control Z. It's your friend. Control Z on your keyboard, or you can see up here, there's the undo button. Okay. And then if you decide, hey, I don't really want that object, you can put it in the trash. And if you're like, oh, didn't mean to do that, just Control Z, it'll come right back. Okay. Now let's do a quick lesson in, I'm going to zoom in just a little. Here we go. Where to click. Okay. Notice no objects are selected right now. Okay. If you have brought an object over and you want to test your skills or learn some ways to manipulate your object, click on one. All right. I'm going to select my cube here. All right. So I've clicked on it. Now, when I click on it, just like if you're doing a slide deck and you click on an object, you get the handles. We've got some different kind of handles we see here. We see our curves here are our X, Y, and Z axes. And so you can spin this around. If you click while it's got the radius there, you can either type in, me hover and see if that 0 will stay. There it goes. You can actually type in where that 0 is and say, I want to shift this 90 degrees, and it will. All right. You can click on one of the handles and drag this out, but it is in proportion. When I brought it over, it's in a perfect cube. If I just click and drag that out, it's going to quickly get out of proportion. So let me back up and do Control Z. If I want it to stay in proportion and I'm going to click a handle, then I need to hold down what? You guys probably know, right? Hold down my Shift key. Sometimes students have to be reminded of that. So if I hold down Shift and I grab it, now it stays in proportion. I still got my cube, but now we're at 34 instead of 20. Okay. So there's enlarging or minimizing your object. If you want to make it bigger or smaller in proportion or not, just hold down Shift if you want it to stay in proportion. And then if you want to just lower the top, like the Z axis, you want to bring it down. So right now we're at 34. Let's just say, no, I just want this to be a little lower because the taller it is, the longer it'll take to print. So maybe I want to bring that down to 18. So that's when you click on this little square in the middle. Now, some of you are probably wondering, what's this little cone that I see up here? Good question. That's actually going to lift your object up off of the base plate. So if we click on the cone and we drag up or with our mouse, now everybody's hanging out on the base plate except for my little rectangle right there. And I can pull this up and show you. I click front, see that? So sometimes you don't know that it's hanging out up in the air until you look from this direction or from this perspective. All right, so I know we're coming up on 4:30, and I wanted to get to a couple more things to show you here in Tinkercad. Visit Tinkercad Classroom, and then just share a couple of takeaways for you. Once you have designs on your base plate, just know you can actually save one of these as a printable. And the file type for those is STL, Standard Tessellation Language File. So a lot of us are familiar with .doc or .ppt or a PDF or a JPEG, right? Add another file name to the list of the ones you know. This in 3D is often going to be the STL file that we want to export. Some of you might have experience with this if you have a Cricut or a Silhouette, because while that is subtractive manufacturing and 3D printing is additive manufacturing, the file type is the same. So if you're used to designing that way, that could be a benefit. I'm honestly better at 3D design in here than I am at my Cricut, but I just probably need to practice more. All right. We've got some objects. You can export these all as one file, or like I said, you can export them one at a time. When we're finished with our design and we want to download it or export it, we want to click up here in the upper right corner on Export. Now, notice that there's two tabs at the top of this window. I can download it to my computer as an STL. I need to click STL. I'm seeing if it's going. Yep, there it goes. I don't know if y'all can see it pop up, but it just popped up here. And then I can bring that over onto a flash drive or save it in my Google Drive, or I can put it wherever. Now, it isn't going to open unless you're in a CAD program, but you can store it, okay? And you can move it around if you need to. Oh, did not mean to get rid of my window there. Hang on. Okay. Also under export, you can go ahead and send it to your slicer directly from Tinkercad if you're ready. Now, a lot of these are brand specific. So if you have a MakerBot printer and you just want to go ahead and export as a .MakerBot file, getting it ready for your printer, you can do that. And then you'll see here that there are quite a few others. Pictures out of the way. So that's just meant to help it be super quick. Okay. If you're looking for a slicing program because your brand of printer didn't have one, I would invite you to try Cura. You can install Cura if you have a Windows-based laptop with a hard drive, but there's also a version of Cura that can be accessed through a browser. So, in other words, if students have a Chromebook. Now, teaching students to slice, that's way down the road. I wouldn't even worry about that at first. Eventually, yes, if you teach anywhere from probably third, fourth grade up, they can learn to slice their own designs. But you really just want to focus at first on the 3D design, saving as an STL, and that is what you would be able to collect in Tinkercad Classroom. This go away again. Oh, it does not want to move. Okay, there we go. Pernell, any pressing questions in the chat that I should address before moving over and talking about Classroom?
I don't see any at this time. There's just a lot of messages letting you know the different type of printers that were being used or that they have at their schools.
Great, okay. Yeah, that's always helpful because, and sometimes new ones come out of nowhere. You guys find it, order it, and we're like, oh, I've never heard of that one. It's really impossible to know all of the printers. Between Purnell and me, we probably have about 5 or 6 types.
Yes.
Yeah.
Yeah.
So we try to stay up on all of them, but it's kind of hard. We've got them anywhere from $300 to about, I think that Dremel probably costs 2,500.
Yes. That's
Lots of
about
range.
right.
Smaller base plate, fewer things you can print at once. What it comes down to, and usually those are less expensive. Okay, Tinkercad icon in the upper left is your home button. So if you're finished designing, it's going to save automatically. It's going to hang out in my library now. You can see other designs that I've been playing around with. Some of these I find and I bring them over. Others I design from scratch. Depends on what my goal is and what I'm maybe pressing myself to learn. As a teacher, you should see a tab over here on the left that says classes. So collect up some designs, spend some time in the tutorials, take a look at the challenges, look at their gallery because there's lots of ideas in there as well. If you're going to have your students designing, that's when you want to click on classes. So this is just the quickest, easiest way I know to keep your students safe, where you can see what they're designing, and you can even assign them an activity or a tutorial to complete that more guides them. Because you can probably guess, what do students get most frustrated with when they get into Tinkercad? Anybody want to share that real quick? Where to click, maybe. They don't know. They just start clicking on handles and moving things around, and they don't know their object is hanging out up in the air or that it's way up front. And so just teaching them those key parts will keep the frustration level lower. Okay. They'll have much more success in designing. All right. So you can see here that I have several classes. Some of these are from teachers who have done the designing with their students and they invited me as a co-teacher. So that's neat too, that even though I'm not their teacher, I can still see and help print their designs. I want to create a new class, so I will give my class the name. And I will go ahead. Ooh, it is spring 24. Okay. And then I can select the grade level and subject, but I don't have to. And just like that, I create a class. Now, you can generate a generic list. You can create a generic list of student names, usernames, and passwords for this, which is often what I have to do because I often don't teach those students. But for you all, you probably just want to import your students' names, but it'll generate a list. You can snip these apart and give them out for them to use so they know their username and their password to get in. And then once they're in, you don't have to do that part again. They're just a part of your class. You can send code. Well, okay, so here's my new class. I don't have any students in there, but if I click here, I can get back to my properties if I need to change anything. And then I can click on the class and open it. So this is where I can find a shareable class link. I can direct add students, or I can click on class roster and print. So that's that list I just showed y'all. There is also a link. See, there's a little code they can join with. And then once the students are in, go back to a class where I have some students in there. That's when I can see all the students. I can click on designs and I can see all of their designs. It even shows who did what design. And then I can open these myself, slice it, and print. So if you're thinking about scaffolding this out, like initially, you're going to want to hold more of the reins and really encourage students to just focus on designing and export as an STL or not if it's just saved in here. And maybe Cornell said, send them some feedback, send some comments, help them out with what they could maybe change or tweak about their design to make it better. And then work on teaching them how to export it and slice it to get it ready for printing. Okay. One thing that I find a little frustrating is navigating back. So I'm just going to use my back arrow. That's not always the answer, but in this case it is, because I find myself having to start all over again. If there are any co-teachers that you want to add, you can do that here. And then activities, this is what is new in here, is where you can say, you know what, this is my student's first project. I just want them to all do the same thing and personalize a luggage tag. Great. So you can open up the luggage tag activity. It's already pre-made, but you can open that up, bring it into activities, and then all the students will be assigned that to do first. Because once they've learned the ins and outs of designing, then they'll be ready to do more of a from scratch design. Okay. And like I said, just use your back button if you're navigating around in classes, because it's not the friendliest. There's not really a breadcrumb to follow. Okay. And then you always have your list of students. You can remove students or add new ones as the year goes on. And that just makes it really convenient and the safest interaction for you and your students who are 3D designing. Okay, so we looked at quite a few things in Tinkercad already. Like I said, I made these as quick links for you. Before we wrap up, I also wanted to mention Thingiverse. You can run into some not very appropriate for student type designs. If you just freely send students to Thingiverse, I would not do that. But for you yourself to go on here and get inspired, nothing wrong with that. I will say, just because I never know what's going to show up in the library on Thingiverse, I often just come here, thingiverse.com, and I click immediately on education. And that will take us to a place where we can search by our grade level and content area for designs. Ultimaker is now the owner of Thingiverse. They also make MakerBot, but that was not always the case. That's not how Thingiverse started out. Like I say, there's some questionable things that'll come up, like weapons and inappropriate stuff. Just trust me, don't send your kids on the regular Thingiverse. But here is a place where you can go in and say, I'm a science teacher. I'm looking for maybe 8th grade. And you can apply filters and then see what designs come up. And you will just be amazed at what people 3D print. And so these are designs. Some of these now might be for different filament types and specific printers. So you do want to open up the details before just pulling it and thinking, oh, I'm going to print that. Yeah, it happens. Sometimes you just get excited and you're like, I've got to have that. But make sure you look at the details. And when you go to pull a file, I'm just going to chance clicking on one. You can click on download all files, but what I usually do is peek down here first at any notes. See the notes right there? And the person who created this and posted it will give you a heads up. Like, hey, this is what I did. Here's how I did it. Just be aware. May not work on all printers. Then click on files. And what's that? This has got 3 different ones. Okay, I was going to say sometimes there's others, not just STL files, but you can see this one has to be printed in 3 parts. Okay, you can also read reviews from people who have printed this. So there's lots of really neat things about Thingiverse EDU, the EDU version, and Thingiverse regular. But again, watch out for anything that you might not want to see or doesn't really apply to us. But yeah, that's a quick look at Thingiverse, and I like that for inspiration. There's another site called Yegi. It's YEGI, if you're interested in another place to go, just to take a look at what other people have put out there. So I know we're running low on time. I can scan and share this if you would like, but you can actually print this off of Tinkercad. It is under the Tinkercad.com/sheet, and it is a 1-page front and back glossary of terms. And this for you will be helpful, but also for students. The terms are not terribly difficult, but they are just the basics, the ones you want to know. So you can comfortably talk about 3D design. And so that is tinkercad.com/T that you can printable. And then another one that I have is the keyboard shortcut. This can be helpful and like the
Your sound fading out, Angie.
Sorry.
When you had your paper up, your sound faded out.
Oh, I'm sorry. I know to stay in the sweet spot, but this is a great printable for them, and it's just a shortcut list, the shortcuts in Tinkercad. Honestly, I think that you could easily do a beginner lesson for students in 30 to 40 minutes and help build that foundation. And then from there, add different things for your students to do in Tinkercad that just build their skills. And if anyone has an idea for other first projects, I bet some viewers, some participants would love to see just what all do people start with when they do Tinkercad.
Yeah, and they have that in Tinkercad too, as far as first projects and starter projects and work along. So those are options as well. Yeah, when you go into those and resources, yeah. So that's a great place to start.
Yeah. It's just so exciting to think about what am I going to print next? And that's the place where you can teach your students to think innovatively and what are the possibilities. We might need to solve a problem where water isn't as clean as it should be. There are 3D projects out there you can find where you can build a filtering system that will clean water. So like real world problems can be solved fairly inexpensively with 3D printing. And it starts with design. So enjoy. I hope you guys get bold and get in there and do some Tinkercad designing and let us know how we can help. We're here.
Thank you all so much for joining us today.